Now, regarding the protocols, and we are discussing further to the ARP protocol. We have also discussed a bit about ICMP protocol, that is Internet Controlled Message Protocol. There is a good reference for all these protocols, and in general for TCP/IP, and that is a book by a well-known author Horizon, Data Communications and Networking. And the complementary slides are also given as a part of this, which I'll be presenting for your benefit. So we have seen the address mapping. Address mapping is basically important because there are logical and physical addresses, and unless address mapping is done, the data transmission and reception cannot happen over the network. So this address mapping, basically, there are two things: mapping logical addresses to physical addresses, and mapping physical addresses to logical addresses. And we have seen that address resolution protocol is basically used for all these applications. And even we have seen that ARP request, ARP reply, these are the part of this address resolution protocol. Here also one example is given. I gave one example in the last video. Here also example of a system A, which is placing a request, ARP request to system B to find out its physical address. So this is done by specifying the IP address of the other machine, which is basically sent to all the machines, and wherever there is a match, so that machine responds, and that response is called as ARP reply. And in the ARP reply, the machine gives the MAC address. So in this way, this particular process happens. ARP request is a broadcast request because it is supposed to be received by each and every machine. However, ARP reply is unicast because it is specified to the machine which is required the particular physical address. For example, here in this case, the address ARP request from system A to system B is a broadcast request. It goes to all each and every machine. However, the ARP reply is going only from system B to system A. So it's a unicast kind of reply. So ARP can be useful if the ARP reply is cached, kept in the cache memory for a while, because this will help in speeding up the entire process. The ARP packet format we have already discussed. The 32-bit format is there, in which there is a hardware type, hardware length, protocol length, operation is specified. The center hardware address is specified, center protocol is specified, target hardware is specified, and target protocol is specified. The details are already discussed in the last video. The encapsulation of ARP packet is done, and the details are as shown here. The ARP request or reply packet, it is encapsulated, and there is a preamble, destination address, source address, because this is a unicast process, and which is padded by CRC, which is nothing but the error detection and correction mechanism. This particular slide specifies the four cases using ARP. So in the case number one, here you can see a host has a packet to send to another host on the same network. So both the sender and receiver, they are onto the same network, same LAN. In case B, case 2, a host wants to send a packet to another host on another network. Okay. And as you know, that if this is to be accomplished, then there has to be a router because you are going out of LAN, and the router, through router mechanism, this can be done. Now, in case 3, a router receives a packet to be sent to a host on another network. So it must be first delivered to the appropriate router. So here this case is that there is a router which receives a packet, and the packet is supposed to be sent to another host. So the router must get the packet first. And case 4, which is discussed here, a router receives a packet to be sent to a host on the same network. Okay. So this is a router, it receives a packet, and this packet to be sent to the host on the same network. So it can also happen. So in this way, these four possibilities are discussed in detail in that book. So the very important thing, which is from the networking point of view, that ARP request is a broadcast, and ARP replies unicast. So this must be kept in the kept in your mind. Few examples are given, so we'll skip this because uh, we can discuss this in further chapter number 4. So we'll skip this example and even the conception of proxy ARP. So even mapping physical to logical addresses. What we have seen is mapping of logical addresses to physical addresses. So for mapping physical addresses to logical addresses, again RARP can be used on bootp or DHCP. Okay, so these protocols can be used for mapping physical address to logical address. So this happens when a disk click station is just booted or organization doesn't have enough IP addresses to assign to each station. Then you can use DHCP, so which is well-known protocol, so that you can assign the temporary dynamic IP addresses as soon as the machine gets booted up. The reverse address resolution protocol, which is of much interest. In this particular protocol, a machine can use the physical address to get the logical address using RARP. So it is a process in which the physical address is mapped to logical address. So here, using RARP, which stands for Reverse Address Resolution Protocol, a machine can use the physical address in order to get the logical address, right? So here, what the mechanism is all about, the RARP messages is created at the outset and they are broadcasted on the local network. Again, the machine on the local network that knows the logical address responds to RARP reply. So whenever there is a match, it responds to the RARP reply. This particular, the entire broadcasting is done at the data link layer, and broadcast request does not pass the boundaries of a network. So that's important from network traffic point of view, that it doesn't pass the boundary of the network. This is how the RARP works. So we discussed the ARP as well as RARP. A very important takeaway is DHCP provides static and dynamic address allocation, and this can be either manual or automatic. So as soon as there are not enough IP addresses, static IP addresses, then even you can go for dynamic DHCP, so that as soon as the machine gets booted up, then you get the temporary IP address from the server. A bit about DHCP. It is dynamic host configuration protocol. The main aim of this protocol is to dynamically obtain the IP address from the network server. So this happens when there are many nodes are there, and most of the nodes they get into the network on a temporary basis, or uh, there is actually lot of nodes are there, and very few IP addresses are there, static IP addresses. So in that case, the dynamic host configuration protocol is of much use, and this can renew its lease on address in use. Okay, so basically to reuse the IP addresses, right? So the IP address can be reused because the machines which are getting into the network, they are uh, on a temporary basis, or as per the demand. So whenever the machine is coming into the network, then the DHCP offers the basic IP address to that particular machine. This is especially useful for the mobile users who would like to get into the network as per their requirement. So this DHCP is really useful in that case. And basic overview is DHCP discover message, which is broadcasted by the host. The server, as soon as the comes into the picture, or the host gets booted up, it sends the DHCP discover message. So where is the server? The message intends to discover the server. To this particular message, DHCP server responds with DHCP offer message. After that, the host requests the IP address because the server responds to the host. Then the IP address is requested by the host, and it comes with the DHCP request, and DHCP server sends the address. So this is with the DHCP acknowledgement message. So this way, the entire handshaking takes place. So this is the scenario. So there is a DHCP server. So first of all, the DHCP discover message is sent by the host. So after that, suppose this particular mobile host is getting into the network. So it requires a temporary IP address. So it sends a message to the server. So this is the DHCP discover. So to this DHCP server responds with DHCP offer message. It responds to DHCP offer message. The host again requests the DHCP request. So after this initial handshaking is done, the mobile host, it will ask for the IP address. Okay, and to this the DHCP server will send the acknowledge address with the IP address for the mobile host. So this is how the entire handshaking takes place in the network. This is what is described by using the flowchart, that the entire process of discovering the server, after that offering the address to the mobile host. So entire thing happens, and this particular DHCP, this UDP on port 67 and 68, we'll see the details in the later part of this presentation. So this is regarding the entire thing regarding DHCP. A bit about ICMP. So ICMP, as we have seen, stands for the Internet Control Message Protocol. So this is a mechanism used by the host or routers to send notifications regarding the datagram problems. So this is a sort of diagnostics or troubleshooting kind of protocol. So wherever there is a problem with the datagrams, so this protocol is put to use. And as we have seen that this protocol has got two parts. The first part is ICMP test, and this ICMP test is used to test whether the destination is reachable or not. And then if the destination is reachable, then it will respond with the ICMP reply. So the core responsibility of ICMP protocol is to report the problem. Okay, it doesn't have the ability to correct them, and the responsibility of the correction lies with the sender. Right. So ICMP can send the messages only to the source. It cannot send messages to the intermediate routers, because the IP datagram carries the address of the source, and the IP datagram doesn't have the address of the router which is doing the internetworking part. So in this way, the ICMP reply will go to the source only. This is the general format of ICMP message. So type, code, checksum, and rest of the header of the message, and then there is a data section. So this way, uh, actually, the ICMP test is actually sent by the host, and to this test there is a reply message which is sent by the destination machine. A important takeaway in case of ICMP is that ICMP always reports error messages to the original source. So it doesn't report the error messages to the intermediate router or something like that, because it doesn't have basically the address of those routers.